Okay, so I'm going to give you what's called an arithmetic sequence, and then we're going to see if you can figure out why. So here's the numbers. -3, -1, 1, 3, 5, ... Now, anybody know why that is called arithmetic? So it's a sequence. We've worked with sequences. What makes it arithmetic? Max?
There's a rule to it?
Yes. Tell me about the rule to it.
It would be,
Pattern would be
+2.
+2 every time.
Yes.
Everybody agree? +2, +2. So what makes something arithmetic is when you, go ahead Max.
Have like a reason like why the numbers are in a sequence.
Right, and what are you doing every time to get the next number?
Adding.
Yes. So it's when you add or subtract to get the next term. That 2 that we're adding every time has a name, or actually a variable. It's labeled D. Stands for the common denominator, common difference. Common difference. So that's that number 2 that Max said we're adding by every time. But if the common difference isn't obvious to you guys, here's how you find it. You take a sub 2. Anybody remember what a sub 2 stands for? First of all, the letter A has meaning. It stands for a word.
Is it the answer in the second
Position. Yes. So it's the answer in the second position minus a sub 1. So the common difference will always be the answer in the second position minus the answer in the first position. So, Nat, for this, I know it's obvious. Max already told us the common difference is 2. But tell me, what's the answer in the second position in this sequence?
Are you asking for...
Just the answer in the second position.
I'm not sure what you mean.
That's okay. Anybody got answer in second position, Hannah? It's -1. And then the rule says minus. And then Nat, what's the answer in the first position?
I get 3.
Good. And that's another way for us to get that +2. That the common difference was +2. Obviously, you guys are smart enough to see what it is. I'm just saying if you're in a situation where you can't see what it is, you always do that. Okay? The graph of an arithmetic is always going to be linear. So arithmetics always graph as a line. Always graph as a line. Yes, Miss Hannah?
Never mind. I was just going to say, is it always like the same? Like you always use a 2 minus something?
Yes. Okay. And still, keep in mind, we still have term numbers. When n is 1, when n is 2, n is 3, n is 4. So there's nothing different there, guys. Okay? All right. Now, for an arithmetic sequence, instead of getting the rule off your calculator, which you could, I'm going to need you to use a formula to get the rule. Okay? So this is the formula for the explicit rule. For n, can I abbreviate? I don't like to write arithmetic sequence like 20 times. Can I abbreviate it AS? So the explicit rule for an arithmetic sequence. So I'm not going to let you just get them off your calculators. Nat, put that away, please. Okay? So the explicit rule is a sub n equals a sub 1 plus, and for some strange reason on assessments, people forget the plus. And then all things go bad. N minus 1 times d. So let's identify what we know. A sub n is the answer. Remember, A sub n stands for answer in any position. Anybody know, raise please, what A sub 1 stands for? So what does A sub 1, Brianna, stand for? Yes, very good. Answer in the first position is what you said? Anybody know what n stands for in a sequence? Leah?
Would it be like the... Oh, never mind.
That's okay. Help her out. What does n stand for, Max?
What position is in?
Yeah, so the term,
Term number.
yeah. And d we just defined. So d is the common difference. Okay, so one more thing, very important. When you write this rule, it has to end up in y equals mx plus b form. Why? Because it's linear. So in other words, it has to be simplified. Doesn't mean you have to put x's and y's in it. It just means you have to simplify. Okay? Right? And then I'm going to give you, the only other one I'll give you right now is the recursive rule. So the recursive rule for an arithmetic sequence. Okay? Remember, recursive always goes in brackets. Recursive, always give me that first term, the first answer. Recursive always gives a rule for a sub n. Recursive always tells you to look back 1. Very good. So the recursive rule is a sub n minus 1. So look back 1 term. So remember, that's all that means, is look back 1 term. And add on d, the common difference. Sir, check whether the sequence is arithmetic. So all you have to do is see if you're adding or subtracting something every time. Now remember, if you're going to use the formula, the common difference is the second term, 27, minus the first term, 32. What does that come out to be, Kayla? Negative? Negative what? 27 minus 32? So negative 5. All right, so 32 minus 5 is 27. Remy, is 27 minus 5, is that 21?
No.
No. So our answer, big fat no. Okay, that was easy, right? Next one. Write a rule for the nth term. Now they're telling you it's arithmetic. Then they want you to find a sub 22. A sub 22 is the 22nd term. Okay? So let's, guys, go ahead and find D first of all. So Joel, what would be my setup to find that common difference? What minus what? Yeah, so what's A2? I believe that's the first term. So 5 minus 9. And that comes out to be -4. Everybody good with that? Okay. All right. So now we're going to use our model. Now, do you have to write down the model every time? No, you don't. A sub n equals a sub 1 plus n minus 1 times d. So we're just doing the rules, so we're going to leave a sub n as it is. A sub 1, and that's the first answer, 9. N is the term number. We don't know what term number quite yet because we're just getting the rule. And then D is the common difference, which is -4. Now here I have an issue, guys, because you know what? If you do it like that, doesn't it look like -4? Okay, but it's not -4. It's times -4. All right, make algebra teachers proud. What property is that? All right, so now we have 9 plus -4n plus 4. And all we have to do is we have to simplify that. So a sub n equals -4n. And then what, gang? Plus, careful, 9 and 4, 13. It's 9 and a positive 4. Careful. So that's the rule, and then they want you to find a sub 22. So that's -4 times 22 plus 13. Okay?